Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to continue on in our Unit 6 lessons. We're doing Unit 6 Lesson 3, and today should be mostly a review of things that you learned in Algebra 1. So that's the good news. We just need to review the laws of exponents, make sure that our skills with simplifying expressions with exponents are freshened up and ready to go for relating them to radicals and rational exponents at the end of the lesson, and then in lesson 4 as well, we'll be doing that. Don't forget to put your first and last name, period, and the date in the upper right-hand corner. Our objective today is I will use the laws of exponents to simplify expressions, and mastery will be demonstrated by scoring at least 80% on the extra practice. So, as you can see, we've got all the laws of exponents listed here. Our first law is the product of powers. And by definition, the product of powers says that if you multiply two terms, so if you multiply two things and the bases are the same, so here we are with a base A and a base A, you add the exponent. So this exponent was M, this one was N, we add them. We combine them into one, and then we add the exponents. And notice that the base stayed the same. The base stayed as A. So when I take 2 to the third times 2 squared, again, my bases are the same. They're both 2. I'm going to keep that same base of 2. I'm going to take the exponents, 3 and 2, and I'm going to add them. So 2 cubed times 2 squared is equal to 2 to the third plus 2. And 3 plus 2 is 5. So we have 2 to the fifth. And then you could go ahead and multiply that out, 2 times 2 times 2 times 2 times 2, and let me know what that is. But for the sake of this lesson and our examples, I'm just going to leave it as 2 to the fifth. Now we have a to the m over, this definition is the quotient of powers. A to the m over a to the n. Again, these bases are the same. When I divide and I have the same base, I can again combine them into one with the same base, and then this time I subtract my exponent. So a to the m over a to the n becomes a to the m minus n. So here we have 3 to the fifth over 3 to the fourth. Well, then the bases are the same. They're both 3. We keep that base. We subtract the exponents, 5 minus 4, which would be 3 to the first, or just 3. I realized I forgot to do my example using variables over here. So x to the fourth times x to the third. Our bases are the same. When we multiply, we add the exponents, so it becomes x to the 4 plus 3, which is x to the 7th. For y to the 7th over y to the 3rd, again, our bases are the same. I keep that same base, and I take the exponents 7 and 3, and I subtract them. So y to the 7th minus 3 is y to the 5th. All right, now for a power of a product. So, no, just kidding, we have to do power of a power. For power of a power, that means I'm taking a base with an exponent to a power. So a to the m to the n is the same thing as a to the mn, which means multiplication. So these are being multiplied. So what that really says is a to the m times n. So for 5 squared to the third, that means we have 5 to the 2 times 3, which is 5 to the 6th. Y to the 10th to the 2nd would be y to the 10 times 2, which is y to the 20. All right, now we're going to take the power of a product. So product just means like multiplication. So a times b is a product, and we're taking that product to the power of n. So a times b to the n, or ab to the n, is the same thing as a to the n times b to the n. So as you can see, it's kind of like distribution, but don't tell anyone I said that it's distribution. You take that m and you apply it to the a and the b. So it becomes a to the m and b to the n. So 3 times 2 squared is the same thing as you take 3 to the 2nd times 2 to the 2nd. Xz to the 3rd to the 4th. You take x to the 4th and z cubed to the 4th, so you multiply 3 times 4, So this becomes x to the 4th times z to the 12th. But we don't need that multiplication sign in between them. We can just write them next to each other and understand that it's multiplication. So xz to the 3rd to the 4th is x to the 4th z to the 12th. All right, now for a power of a quotient. That means we're taking something that's being divided, a over b, and we're taking that to a power of m. Again, you just apply that power to everything in the parentheses. So you get a to the m over b to the m. So if I do that here, I'm going to have 3 cubed over 2 cubed. Y to the 10th over x to the, y over x to the 10th would be the same thing then as y to the 10th over x to the 10th. All right. A negative exponent. So whenever you have a negative exponent in an expression, it's not simplified until every single exponent is positive. So a to the negative m would be the same thing as 1 over a to the m. So what we do is a to the negative m is technically 1. And we just move it to the denominator, and that makes the exponent positive. And then we keep the placeholder 1 in the numerator. So 2 to the negative 1, remember, technically this is over 1, so we're going to move it to the denominator to make the exponent positive. So we keep our placeholder 1 in the numerator, and then we get 2 to the positive 1, which is just 2. So 2 to the negative 1 is the same thing as 1/2. So b to the negative 2, remember, b is technically over 1. B to the negative 2 is technically over 1. We're going to move it to the denominator. Keep your placeholder 1 up top, and then b to the 2nd. So once that exponent goes to the denominator, it becomes positive. All right. Then identity exponent just means that anything to the first power is itself. So 10 to the first power is simply 10. X to the first power is x. 5 million to the first power is 5 million. Negative 27,000 to the first power is negative 27,000. And then last but not least, our 0 exponent. Anything to the 0 power is always 1. Anything to the 0 power is 1. So 5,473 to the 0 power, you guessed it, it's 1. Z to the 0 power is 1. So anything to the 0 power is 1. All right, for example 1, I actually want you to work through these examples on your own. These are like Algebra 1 level examples. You should be able to do all of these. See how far you can get without me. And then press pause and then press play when you're ready to check all of these answers. So go ahead and give it a shot on your own. All right, so x to the 6th times x to the 4th would be the same thing as x to the 6th plus 4, which is x to the 10th. X to the 5th over x cubed would be the same thing as x to the 5 minus 3, which is x squared. X squared to the 3rd is the same thing as x to the 2 times 3, so x to the 6th. X to the 0 is simply 1. X to the negative 3 would be, remember this is technically over 1, we're going to move it to the denominator, keep that placeholder 1, and the exponent becomes positive. Now the opposite of that, 1 over x to the negative 3, you can actually move this back to the numerator, and that'll become positive there. So 1 over x to the negative 3 is the same thing as x to the positive 3. You got that placeholder 1 in the denominator, but x cubed divided by 1 is just x cubed. So if you move a negative exponent to the denominator, it becomes positive. And if you move a negative exponent from the denominator to the numerator, it also becomes positive. So both ways work. Then x squared y to the 4th. x squared y to the fourth would be x squared times 4, and then y to the fourth. So x to the 8th, y to the fourth. X to the 5th over y cubed to the third, we would take x to the 5th times 3, y to the third times 3, which is x to the 15th over y to the 9th. And there's one more example I want to talk about. Would I be next in the alphabet here? Part I. I want you to do a plus b to the 0. What do you think a plus b to the 0 simplifies to? Go ahead and give that a shot. So remember, anything to the 0 power is simply 1. No matter what you put in those parentheses, as long as the whole parenthesis is being taken to the 0 power, you get 1. Notice a and b are not being multiplied, they're being added. So the power of a product rule doesn't work here. A and b are being added. In the power of a product rule, they're being multiplied. So because they're being added, we don't distribute that exponent. We take the whole thing to that exponent. So this whole thing to the 0 power becomes 1. All right, let's do some algebra 2 level examples. So again, we're going to use the laws of exponents to simplify this expression. 4 squared x to the negative 4th over x to the negative 5th to the negative 1. I don't know why I said over in the middle of that. 4 squared x to the negative 4th times x to the negative 5th to the negative 1, all over 8x squared times x cubed to the negative 2. So let's do the easiest parts first. So let's do 4 squared. 4 squared would be 16, and then x to the negative 4th times, this would become x to the negative 5th to the negative 1 would be x to the 5th, all over. Let's do 8, and then x squared. X cubed to the negative 2nd would be x to the negative 6th. When I take a power to a power, I multiply them. Next, let's simplify 16 over 8. 16 over 8 becomes 2. So then I have 2x to the, whenever I multiply, so I have x to the negative 4th times x to the 5th. I'm going to add those exponents. And then in the denominator, the 8 canceled. I have x squared times x to the negative 6th. Again, I'm going to add my exponents because I'm multiplying. Negative 4 plus 5 is 1. 2 plus negative 6 is negative 4. So now I have x to the negative 4th. To make this exponent positive, I need to move x to the negative 4th to the numerator. So 2x to the 1st times x to the 4th all over. 1 would be left in the denominator. Well, anything over 1 is just itself. And then I have 2. X to the 1st times x to the 4th is x to the 1 plus 4. So I would have 2x to the 5th as my final answer. So we just used a whole bunch of the properties all at once. When I took a power to a power, I multiplied. I got a 5. 3 to the negative 2nd is negative 6. I added my exponents. I took a negative exponent, moved it to the numerator to make it positive. And then I added my exponents again because I was multiplying like bases. We did a whole bunch of properties in one problem. So part B, I want you to go ahead and try this on your own. 3 to the negative 3rd times u to the negative 5th times v to the negative 3rd, w to the negative 5th, all to the 3rd, all over u to the negative 6th, v squared, and then square that, times vw to the negative 2nd to the negative 3rd. Go ahead and give this a shot and just see how far you can get without me. All right, so 3 to the negative 3rd, let's leave that alone for now. U to the negative 5th, let's leave that alone. We're going to take this cube and we're going to apply it to everything in the parentheses here because these guys are being multiplied. V to the negative 3rd times W to the negative 5th. So 3 times negative 3 would give me negative 9. Negative 5 times 3 is negative 15. And then we're going to square everything in the parentheses here. So we're going to have u to the negative 12th, v to the 4th. We're going to take everything in parentheses here to the negative 3rd. We're going to have v to the negative 3rd, w to the negative, just kidding, the positive 6. So positive 6. All right, then I'm going to combine what I can. So v to the 4th times v to the negative 3rd could be combined. Then we have u to the 5th and this negative u to the negative 12th, and then w to the negative 15th divided by w to the 6th. So what I'm going to do is I'm going to take 3 to the negative 3rd, u to the negative 5 minus negative 12. So when I divide, remember, I subtract my exponents. For these guys, again, I'm going to subtract my exponents. I'm going to have w to the negative 15th minus 6 all over. And then in the denominator, I still have v to the 4th plus negative 3. So I'm going to leave 3 to the negative cubed alone for just a second. U to the negative 5 minus negative 12 is negative 5 plus 12, which is 7. V to the negative 9, W to the negative 21, all over. Then down here, I'm going to have V to the 1st. All right, then there's a couple of ways we could go about this problem. We could subtract these exponents because we have division, or we could start dealing with all these negative exponents. So 3 to the negative 3rd is going to have to move to the denominator. V to the negative 9th has to move to the denominator, and so does W to the negative 21st. So all that's left up top will be U to the 7th over, then we have 3 cubed, V to the 1st times V to the 9th, and then W to the 21st. And then I'm going to draw a line and bring this up here. U to the 7th over 3 cubed, 3 times 3 is 9 times 3 is 27. V to the 1st times V to the 9th, we add these exponents, so it would be V to the 10th and then W to the 21st. So U to the 7th all over 27, V to the 10th, W to the 21st. Hopefully our answers ended up matching. And if you did your steps differently, like if you did some other properties before, like the ones I did, you switched up your steps, like that's perfectly fine. All right, so for part C, I'm gonna help you get started. Because we're taking this entire thing to the negative 3rd power, what I recommend you do is that you simplify what's inside the parentheses before you deal with this. And save this thing for last. So simplify everything inside all those parentheses before you deal with this thing. Well, why don't you go ahead and give that a shot on your own, see how far you can get, and then compare steps when you're done. So r to the negative 5th, we're going to leave alone for now. We're going to take all of these things to the negative 2nd power, the p to the 4th, and the q to the negative 6th. So we're going to get p to the negative 8, q to the 12th. Then down here, we need to take all of these things to the negative cubed power. So we're going to have p to the negative 18th, q to the 15th, and then r to the 3rd. And then we're going to take all of this to the 6th. We're going to have q to the negative 6th, r to the 6th. And then all that to the negative 3rd. Let's keep simplifying what we can. So in my denominator, I've got q to the 15th and q to the negative 6th. I've got r cubed and r to the 6th. So let's go ahead and combine those real quick. So I'm multiplying, so I'm going to add these exponents. So r to the negative 5th, p to the negative 8th, q to the 12th, all over p to the negative 18th. Let's see, 15 plus negative 6 would be 9, so q to the 9th. R to the 3rd times r to the 6th would be r to the 9th. And then let's do our division. So remember, when we divide, we subtract our exponents. So we're going to take r to the negative 5th and r to the 9th, which would be r to the negative 5th minus 9. I'll write that a little bigger. Then we've got the p's here. We're going to have p to the -8th minus a -18. Then last but not least, we've got these q's. We're going to have q to the 12th minus 9. And then still all of that to the -3rd. Okay, let's simplify what's in the parentheses here. -5 minus 9 would be -14. -8 minus a -18, that's positive. That'll be to the 10th. And then q to the 12 minus 9 is 7. Before I take care of my negative exponent here, instead of doing that, I'm going to go ahead and take this -3 and I'm going to apply it to each of these. So I'm taking r to the -14th to the -3rd. I'm taking p to the 10th to the -3rd and q to the 7th to the -3rd. So remember, when I take a power to a power, I multiply them. So I'm going to have r to the 14th times, just kidding, -14 times 3. What is 14 times 3? And because they're both negative, they're going to become positive when we multiply them. So we're going to get 42. And then we're going to have p to the 10th to the -3 is p to the -30th. And then 7 to the -3 is, q to the 7th to the -3 is -21. So now r has a positive exponent. We're going to leave that in our numerator. But these two negative exponents need to be moved to the denominator. So we're going to have p to the 30th and then q to the 21st. Whew, so many steps. That's kind of fun, isn't it? So how does all of these laws of exponents relate to what we've been doing with radicals? So here's kind of a sneak peek of how it's related. Our next lesson in Unit 6, Lesson 4, we'll go into rational exponents even more and use the laws of exponents on them. But for today, I just want to kind of like dip our toes into this concept that a radical can actually be rewritten as an exponent. And let me show you how that works. So notice that we have what's inside the radical here is a, and a is being taken to the b power. And we're taking the nth root of a to the b. I can rewrite that as what was in the radical here becomes the base of our exponent. And then the exponent becomes a fraction. And in the numerator of the exponent is b's power. And in the denominator is the index or the root. So the root goes into the denominator, that exponent goes into the numerator. And this also works the same if you have the nth root, just here, the nth root of a, and all of that's being taken to the b, that's still written as a to the b over n. So if the exponent is outside of the radical or inside the radical, it still gets written the same way. So let's rewrite, actually, let me do an example before we do that. So let's rewrite the square root of x in exponential form. So technically, when we take the square root, our index is 2. There's technically a 2 there. And then when you have x by itself, isn't x really being taken to the first power, x to the first? So this gets rewritten as x to the 1/2. So notice the root, that 2 is my denominator of that exponent, and the 1 became the numerator. So the square root of x is the same thing as x to the 1/2 power. So if you wanted to rewrite like the square root of 2 would be 2 to the 1/2 power. The square root of 27 is 27 to the 1/2 power. So the square root of anything is that thing to the 1/2 power. That's kind of like a fun fact that you should have memorized for the rest of your mathematical career. All right, so let's do example 3, part A, the 4th root of 5 squared. So remember, the nth root of anything to the b power is the same thing as a to the b over n. So our root is 4, our exponent is 2. We're going to rewrite this as 5 to the 2/4. But then I can reduce 2/4. So this would be the same thing as 5 to the 2/4. This is the same thing as 5 to the 1/2. All right, let's rewrite the third root of x to the 4th. This would be the same thing as x to the what power? Go ahead and fill that in on your own. So hopefully you have x to the 4/3. Our root is 3, our power is 4, so x to the 4/3. All right, part C. So the square root of xy cubed and all of that to the 5th. So what's happening here, we have x to the, and then 5/2, and y to the, 3 times 5 would be 15 halves. That's going to be our final answer, and let me show you why. So I could rewrite what's in the parentheses to x to the 1/2 and y to the 3/2. Then I take all of that to the 5th. So we multiply 5 times 1/2, 5 times 3/2, and we would get 5 to the 5/2, y to the 15 halves. There we go. All right. Now you're going to go backwards. You're going to rewrite 9 to the 1/2 as a radical. Excuse me. So 9 to the 1/2 would become the square root of 9 to the 1st, or just the square root of 9. And the square root of 9 is 3. So 9 to the 1/2 power is 3. X to the 1/3. Go ahead and write that as a root. So x to the 1/3 would be the cubed root of x to the 1st, or just the cubed root of x. Now try xy to the 2/3. Xy to the 2/3. So our denominator is a 3. I meant to use a highlighter. So that means we're taking the third root of xy, and then this is our exponent, we're going to square it. So the third root of xy squared would also be the same thing as the third root of x squared y squared. Those two things mean the same thing, and I would accept your answer either way. All right, that's it for today. Make sure you do your extra practice now, and I will see you back in class. Have a good day.